Yeah, today we're going to continue talking about hypothesis tests for proportions, and we're going to discuss what to do with that p-value we found last lesson, and also some potential errors that we can make when we're doing a hypothesis test. So last time we talked about this scenario of absenteeism, and we wrote some hypotheses based on the question. We have this assumed proportion of students who had not been absent from school even once, so 34%. And we did a survey 4 years later, and we got a sample proportion of 33% who said they had not been absent. And so what we want to know is, does that give us evidence to show that the actual population proportion of non-absentees has changed? And so we wrote our hypotheses. We had a null hypothesis that we assume, until proven otherwise, that our population proportion is still 34%. And our alternative was that it's not 34%. It changed. We didn't care specifically if it went down or if it went up. What we wanted to know if it's changed, and that's why we chose this not equals to. That's what we call the two-tailed test. Two tails, the right and the left, and we're gathering the area under there, and that represents our probability. That's why we have the 2 here in our notation. And sorry, I typed p hat. I can just write it p hat. That's what I mean. So we're going to know twice the probability that our sample proportion is greater than what we got, which was 33%. And we found through calculating using one proportion z-test that our p-value is 0.055. That's our p-value. This is our probability. It's a probability. What this means is, if our true population proportion of non-absentees is 34%, then there is about a 5.5% chance that we would have gotten our sample proportion to be 33%. So if in truth the real population proportion is 34%, then a sample proportion of 33% has about a 5.5% chance of existing. And so we need to know, now we need to decide, okay, does this have us evidence of a change? It seems pretty unlikely that we get a 33% proportion from our sample if 34% is the true proportion. And so what we need to do is we need to compare to a significance level. And so in here we have this Greek letter alpha. Some people call it fishy. It looks like a backwards fishy. That is called a significance level. We want to set our significance level before we conduct a hypothesis test, but in order to talk about it after I waited. Some common significance levels are 0.10, 0.05, and 0.01. Of course, there could be other significance levels. These ones are common ones. And unless otherwise told, we are going to use 0.05 as our significance. And what that means is, if our p-value is less than that, then we're going to say it's unlikely, not impossible, but incredibly unlikely that we got our sample to be what it was if the population proportion was what the null is. Right, so we always want to compare our p-value to our significance level. So we're going to use 0.05, and you're going to use 0.05 unless you're told in some scenario to use 0.10 or 0.01. We can have discussions about what will happen if you change from one to the other at a future time. But we're going to always compare. So let's compare 0.05 to 0.055. I like to put the p-value on the left always and see if it's bigger than the alpha or smaller than the alpha. Well, in this case, 0.055 is bigger than 0.05. Not too much bigger, but bigger nonetheless. So this is what we have. And so in this case, it's likely to get our sample results if the null is true. It's not incredibly likely. In fact, I might want to take, maybe do another sample, or maybe I want to adjust my alpha. But it's not likely that, or it is likely that we get our sample result if 34% is our true proportion. And so what we do is we say we fail to reject the null hypothesis. And what that means is there's not enough evidence to say what we were looking at. So there's always two possibilities of what we're going to do with our p-value. We are either going to fail to reject the null hypothesis. We're not saying it's true. We're just failing to say that it's not true. Or you can reject the null hypothesis. So had our p-value been smaller than 0.05, we would have rejected the null hypothesis. We would have said it's highly unlikely, very unlikely, not impossible, but incredibly unlikely to get our sample results if the null hypothesis was actually true. This is like the court case. People are either guilty or not guilty. They're not guilty or innocent. We don't prove innocence. We prove guilt. Or we fail to prove guilt. And so what we need to do in a court trial is we need to produce enough evidence to say beyond a reasonable doubt that that crime couldn't have been committed unless it was the person that's on trial who did it. And so that's what we're doing here in a statistics sense. We need to have enough evidence, a p-value that's so small that we could not have gotten our sample results if that original null hypothesis was true. And so you can see I'll either fail to reject or reject. In no way will I ever say accept the null hypothesis. Nope, we will fail to reject. It doesn't mean it's true. It means we don't have enough evidence to say it's not true. And so I think this little chart will come in handy about like how to compare, what that means. Here's what we decide, and then here's how we draw our conclusion, because we do need to make a conclusion about our scenario. So in this problem where we have a sample of student responses for saying that they weren't absent, we wanted to know if there is evidence of a change and our p-value was greater than our significance level. We failed to reject the null hypothesis. So we will say there is not enough evidence. So let me write that up. So much like when we're interpreting a confidence interval, we always want to interpret our results when we do a hypothesis test. We don't necessarily, in our interpretation, need to mention whether we reject or fail to reject, but that either failure to reject or decision to reject our null hypothesis is what's going to inform how we write our interpretation. We always want to establish what was the p-value that we calculated, what was the significance level that you compared it to, and then is there enough evidence or not. And of course we want to have our context in there. We're talking about a change in student attendance. So I think that this chart will give you a guide as to how to write up your conclusion. That's one of those things that the more practice you do, the more comfortable you will get with it. So, of course, when we make our decision and our p-value was very close to our alpha, so it's possible that our decision was incorrect. So we failed to reject the null hypothesis. Even though our p-value was very small, it was still bigger than the significance level we chose. And so it's possible we made a mistake. We did only take one sample. We did only sample around 8,000 students. The population of students in this country, at least, is much larger than that. And so we're not guaranteeing that we're right. We're using what evidence we have to make a decision. And it's possible, like I said, it's possible we're wrong. And to compare it to the court trial, sometimes people go to jail who shouldn't, and sometimes people don't go to jail who should. But a decision is made based on the evidence presented. And so we get in statistics what we call type 1 and type 2 errors. And again, another chart, I didn't create this myself, I borrowed it from the book, so you'll see it in there, but I think it's very helpful. We're comparing what is the decision you made to what the truth is. We'll never know what the truth is. Otherwise, we wouldn't be doing a hypothesis test. If we knew what the true population proportion was of students who weren't absent last month, we wouldn't be doing this. We wouldn't have this conversation. This is more of, hey, what kind of error could we have made? So we failed to reject a null hypothesis. And so if our proportion of 34% is actually true, which we can't know, but if it is, then we didn't make a mistake. But if in reality our proportion isn't 34%, it's something different, then we would call that a type 2 error. A type 2 error occurs when you fail to reject a null hypothesis that in reality is false. When you reject a null hypothesis, if your actual null hypothesis was false, then rejecting it was a good thing. So you'd be okay. No mistakes made. But if you reject a null hypothesis, and in reality that null hypothesis was the true proportion, then you would have made a type 1 error. And this might be one of those things that is challenging to memorize, so maybe you want to use some sort of flashcard or something. So a type 1 error, that's an example of sending an innocent person to prison. We rejected their innocence, said they were guilty, even though they were innocent. A type 2 error is a guilty person going free. So the evidence we had told us, steer us in the direction of failing to reject, even though they were guilty. And you probably know, if you've watched Netflix, that this happens a lot. And so it's possible in our scenario that we can make a mistake, and we just use the evidence that we have to make the best decision we can. So please don't be telling anybody that you have a guaranteed result. The only way to do that is through experiment. So in our problem, as I said, we could have made a type 2 error. And so in context, what that would mean is that we concluded there was no change in attendance. And if we had made that type 2 error, that means we would have come to that conclusion even though there was a change in the attendance. So we determined that we shouldn't fail to reject the null hypothesis and said there's no change in student attendance over the last 4 years. And so if we made an error, that means we said that and there actually was a change in attendance. And so again, this is another one of those things that the more you practice it, the more comfortable you'll get with the wording of your conclusions, just like the wording with confidence interval conclusions, with the wording of what it means to be type 1, type 2 error, deciding which one it is. All this becomes easier and more clear through practice. So what I'm trying to say is you need to practice. As always, if you do have questions, please feel free to ask. I'm gonna reference this same question I referenced in the last lesson for the problems at the end of the lesson. So make sure you watch all the way to the end. Make sure you answer the questions that pop up. Ask for help if you need it. Do the practice I recommend. Good luck.